question to get some understanding of EMF connections. So the question says, three similar cells, each of EMF 2 volt and internal resistance 2 ohms, are connected in parallel. The total EMF and total internal resistance are respectively, so these are the options. So let's quickly do that. So now we have E1, that's cell number 1, 2 volts, cell number 2, 2 volts, cell number 3, 2 volts, and all their internal resistance is 2 ohms. 2 ohms and R subscript 3, 2 ohms. So they said they are connected in parallel. So let's do some parallel connection here. First cell, second cell, third cell. So this is what a parallel connection will be. This is it. This is a parallel when the three devices share the same terminals. That we call that what? A parallel connection. So this is our E1, E2, E3 with their internal resistances. R3. So they are connected in parallel. So the question is, we should calculate the total EMF and total internal resistance. Total EMF. For parallel connections, the voltage across each device will be the same. That is a rule. That is how it used to be. Whenever you have a parallel connection, the voltage you read across each device that is part of that parallel connection will be the same. And fortunately, since all of them are 2 volts, that means the total E total will be what? 2 volts, which is still the same thing as E1, the same thing as E2, and the same thing as E3. So 2 volts is the total EMF. So now the total internal resistance. So this is a parallel connection. And for parallel connection, resistance is analyzed this way. 1 over R total, internal resistance total will be 1 over R1 plus 1 over R2 plus 1 over R3. However, since the three internal resistances are the same, so it's okay if I say 1 over any of the R times this total times what? 3, which is the same thing as 1 over 2. The internal resistance is 2, 1 over 2 times 3. So permit me to bring the calculation this way. So I will have 1 over R total to be 3 over 2. Then when you take reciprocal, or I say you make R the subject, you have that R total will be what? 2 over 3 ohms. So the equivalent internal resistance will be 2 over 3 ohms. And if you convert this to decimal, 3 divided 2 cannot, you write 0, put a decimal point there, add 0 to the 2, it becomes 23 divided 26 times, remainder 2. You add 0 again and divide 6 times, ... So if you approximate that, that will be 0.7 ohms. So the total internal resistance is 0.7 ohms here, while the total EMF is 2 volts. So our option, the correct option is B. Total EMF is 2 volts. Total internal resistance is 0.7 ohms. Thank you.